So what we're going to talk about in this lesson is the probability of what is called a false positive in a test, or oftentimes it's either a drug test or a medical test, but we're mainly going to focus on drug testing. So drug testing is very common for employers. So you go to get a job, they want to hire you, but before they hire you, they'll first send you over somewhere to take a drug test, okay? And there's two possible outcomes to the drug test, okay? And we're going to call those events, okay? And so one event is that you test positive, testing positive means that the drug test has identified you, or the person, whoever takes the drug test, as someone who uses drugs. So testing positive means they think that you are a drug user. But the other event that could occur is that you could test negative, and that's the only two possibilities. You either test positive or you test negative. There is no third option, okay? So testing negative means that the drug test has identified the person as somebody who does not use drugs, okay? So if any person were to take a test, a drug test, that drug test is only going to give one of two outcomes. It's either going to say, well, based on this test, we think that this person uses drugs. Or based on this test, we think that this is someone who does not use drugs. Those are the only two possibilities. But sometimes the tests are wrong. When they're wrong, we call them false. Okay? And so let's see what that, see if we can look at this from a mathematical point of view. All right, so we're going to create a contingency table here. We're going to say that one possibility is that the person actually is a drug user, okay? So each person is either a drug user. The other possibility is the person is not a drug user, okay? And that's true of everyone in the world. Every single person in the world is either a drug user or not a drug user, okay? And then if, let's say somebody takes a drug test, and they either test positive, which means they test as a drug user, okay? The other possibility is that they test negative, and testing negative means that they test as not a drug user, okay? So if the person is actually a drug user and they test positive, that's right here, then the drug test is correct, okay? It's true, okay? We call that a true positive, okay? Because it was correct. It told the truth, okay? It tested that the person was a drug user and the person actually is a drug user. Then we have the not a drug user and testing negative. When the drug test says that this person is not a drug user and they actually are not a drug user, that's right here. That's called a true negative. It's called a true negative. Okay? And hopefully this is what we get. Hopefully when there's a drug test, hopefully the drug test is identifying drug users correctly and identifying non-drug users correctly. But every once in a while, what you'll have is you'll have somebody identified in this area right here. They are a drug user, but they test negative. So they test as not a drug user. Hang on a second here. Don't want this to get confusing here. There we go. They test as not a drug user, but they actually are a drug user. And so we call this a false reading, or in this case, a false negative. Okay? Now, the reason we call it a false negative is because it's saying, it tested negative, it's saying the person is not a drug user, but they actually are a drug user. And so that's why we say that it's false. It's falsely identifying a drug user as not a drug user. Then we have this situation down here where the test identifies the person as a drug user. It's a test positive, but they're actually not a drug user. And so once again, it's false, because it's incorrectly identifying a non-drug user as a drug user. We call this a false positive, okay? And so here's the interesting thing. We like true positives because they tell the truth. We like true negatives because they tell the truth. We don't like false negatives because they're lying. Well, not lying, they're just not detecting the truth. And we don't like false positives because they're detecting something that is not true. And so it's an important area of probability to try and understand, well, what is the probability that somebody's identified as a false negative and the probability that they're identified as a false positive. And so what we're going to do in this particular video is we're looking at the probability of false positives. We're looking strictly at this situation here. We're looking for people who are not actually drug users, but they are testing positive for drugs. All right, so let's look at this question. It says, an employer requires all job applicants to take a drug test. Statistics indicate that 7% of all applicants actually use drugs. So 7% are drug users, and that means that 93% are not drug users. And so what we're going to do is we're actually going to try to understand this using a tree diagram, okay? So we're gonna create the tree diagram though using probability. So what we're going to do is we're going to put a 1 at the beginning of our tree diagram, and then we're going to break this tree diagram off into users, drug users, and not users, okay? Now it says that 7% of all applicants actually use drugs. So 7%, we're going to turn the 7% into a probability or a proportion, and we're going to do 0.07. The way that we turn a percentage into a probability is we divide by 100. So we take the 7%, we divide by 100%, okay? It cancels the percents, and 7 divided by 100 is 0.07, and that's why we put a 0.07 here, okay? And so now what we're going to do is, to find out what's going to go down here, is we're going to do 1 minus 0.07. Well, 1 minus 0.07 is equal to 0.93, and so that's 93%. So we're going to put down here, we're going to put a 0.93, okay? And now it says the test correctly identifies drug users 95% of the time. So 95% of this 0.07, these are drug users, 95% of them test positive. Okay, so we're gonna put here positive. So some of them are going to test positive as drug users, and some of them are going to test, I'm just going to put NEG, negative as drug users. Okay, so we need 95% of 0.07. So that's 0.07 times 0.95. And what we're going to do now is we're going to switch over to a calculator. All right, here's the Numworks calculator. We're going to go into calculation, and we're going to say what's 0.07 times 95%, which is 0.95. And what we get is 0.0665. All right, so we're going to round to 3 places. We're going to say 0.067. So we'll put 0.067, okay? And then whatever is left over is going to go into negative here, okay? And so we have to do 0.07 minus 0.067. So we'll go 0.07 minus 0.067, and that gives us 0.003, okay? So here we'll put 0.003. So it's important to understand, we've done this a couple times now, these two numbers, they have to add up to this number. And these two numbers have to add up to this number. So 0.93 plus 0.07 is 1. And 0.067 plus 0.003 equals 0.07. Okay? Now we'll come down here to the not users. And we're going to have to sort of squeeze this in. We'll make this one positive, testing positive, and then we'll do down here testing negative. Okay? Now you may wonder, well, if these are not the users, shouldn't they all test negative? Yes, they should all test negative. But unfortunately, some people that are not drug users sometimes test positive. That's why we have false positives, okay? All right, let me erase this real quick, erase this stuff, and we'll continue reading the question. All right, so it says, the test correctly identifies drug users 95% of the time. That's why we did 0.07 times 95%, and we got 0.067 correctly identified as, positively identified as users. So these are the true positives. These are the false negatives. Okay, so they are drug users, but they tested negative. So these are the false negatives. All right, then it says, however, the test incorrectly identifies non-users as drug users 4% of the time. So 4% of this 93% are going to be positively identified. So that's 0.04, that's 4% times 0.93, okay? So we're taking this 4% and we're multiplying it by 0.93, okay? And we get 0.04 times 0.93, and that gives us 0.037, okay? We'll round the 7, so 0.037, so 0.037, and now we need to do 0.93 minus 0.037. So 0.93 minus 0.037, and that gives us 0.893. 0.893. And so if we add 0.893 plus 0.037, we get 0.93. And if we add up all four of these numbers, we're going to get 1, okay? And so now we've got our tree diagram created. Now we can answer the question. It says, what is the probability? What is the probability that the applicant tests as a drug user but is actually not a drug user? So they test as a drug user, but they're not a drug user. So this is a conditional probability question. So it's asking, what is the probability? And we're going to do this backwards. I'm going to say given, I'm going to tell you what we're drawing out of. Given that, okay, what group are we drawing out of? Well, we're saying that the person tested as a drug user. So they tested positive. So they definitely tested positive. What's the probability that an applicant tests as a drug user, but they're actually not a drug user? So now we're going to say, what's the probability that they are not a drug user, but they tested positive? So out of all the people that tested positive, they are not a drug user. So what we're going to do is we're going to put all the people that tested positive, or the proportions of all the people that tested positive, in the denominator. Well, here's a test positive, 0.037. So we're going to put that here, 0.037 plus. And then these people tested positive too, 0.067. So plus 0.067, okay? But in the numerator, we want the people that tested positive, but they're not drug users. These people that tested positive, they are drug users. But these people that tested positive, they are not drug users. So we're going to put 0.037 in the numerator, 0.037, right? So we're always going to put one of these two numbers in the numerator, but we're putting both numbers in the denominator. And so this is now going to be 0.037 divided by, we're going to add 0.037 plus 0.067. 0.037 plus 0.067, and that gives us 0.104. So 0.104, and now we're going to key this in. We're going to do 0.037 divided by 0.104. 0.037 divided by 0.104, and that gives us 0.3557. This 5 is going to be rounded up to a 6, so it would be 0.356. All right, so this equals 0.356, and that's our final. Oh, this says round your answer to 4 digits after the decimal. Whoops. All right, let's go back and we'll say 0.35576. This 6 is going to make this 7 and 8, so it'll be 0.3558. So it's going to be 0.3558. And so we'll put in this box 0.3558. Okay, let's try another example. All right, this is a very similar question. It says employer requires all job applicants to take a drug test. Statistics indicate that 5% of all applicants actually use drugs. Okay, so we'll start with a 1 here, and then we have the users. We have the users, drug users, and the not drug users, not users. Okay, it says that 5% actually use drugs. So that's 0.05. 5 divided by 100 is 0.05. That means 0.95 are not drug users. And 0.05 plus 0.95 equals 1. Now we want to split the users up into those that test positive and those that test negative. Okay? And it says here, the test correctly identifies drug users 93% of the time. So here we need to do 0.93 times 0.05. By the way, I'm going to erase this in a minute, so don't actually write this here. I'm going to put a number here, but that number is going to be 0.05, that's this number, times 93% of the time, because it correctly identifies them 93% of the time. So I'm going to do 0.93 times 0.05. That gives me 0.0465. Since I'm rounding to 4 decimal places in the answer, I'm going to go to 4 decimal places here. I'm going to put 0.0465. So I'm going to erase here, and I'm going to put 0.0465. 0.0465. Okay, and then I have to do 0.05 minus 0.0465. So 0.05 minus 0.0465. That gives me 0.0035. So 0.0035. If we add these two together, we get 0.05. Now I'm going to do the non-users. Okay. So the not users, some of them are going to test positive and some of them are going to test negative. Okay? And so it says, however, the test incorrectly identifies non-users as drug users 4% of the time. So 4% of these 0.95 are going to accidentally test positive. That makes them false positives. Okay? So we're going to do our 0.95 right here times 4% times 0.04. Okay, so 0.95 times 0.04, and that gives us 0.038. 0.038. So let's erase here, and we'll put in 0.038, and then to get this number here, we're just going to do 0.95 minus 0.038. 0.95 minus 0.038. That gives us 0.912. 0.912. And to make sure you got the right numbers here, you can add up all 4 of these numbers and make sure they add up to 1. Add these 2 numbers, make sure they equal 0.95. Add these 2 numbers, make sure they equal 0.05. And so now, what is the probability that an applicant tests as a drug user, but they're actually not a drug user? So again, this is the probability that they are not a user given that they test positive. So they tested positive, but they are not a user, okay? And so the test positives are 0.038 plus 0.0465. So we're going to put 0.038 plus 0.0465 in the denominator. and then not a user but tests positive. Not a user tests positive is 0.038. So 0.038, okay? And so we're going to put this in the calculator. We're going to do 0.038 divided by parenthesis 0.038 plus, let's see, 0.0465. 0.0465, close the parenthesis, hit execute, and we get 0.4497. So it's 0.4497. And so in this box, we're going to put 0.4497, okay? Now we're going to do one more example of how to do a false positive. Let's look at this question. This is question 19 on one of the homework assignments. It says an employer requires all job applicants to take a drug test. The tree diagram below is used to summarize the probabilities of testing positive or negative for drug use based on whether an applicant is a drug user or not. It says that A, that's right here, is 0.064. So we're gonna start with the 1. We're gonna redraw this. We're gonna say 1, and then we're gonna say users are over here and not users are down here. Okay, and it says right here we're gonna put 0.064. 0.064. So to know what number to put here, we're gonna do 1 minus 0.064. So we're going to go to the calculator. We're going to do 1 minus 0.064, and we get 0.936. So here we're going to put 0.936. Then it tells us that right here, we're going to put, for B, we're going to put in 0.046. So 0.046. To find out what number we're going to put here, we're going to do 0.064 minus 0.046. Okay, so this is what we put here is going to be, well, let me write it down here. 0.064. We're taking this number and putting it down here minus this number, 0.046. And whatever number this is, it's going to go right here, okay? All right, so 0.064 minus 0.046, 0.046, and that gives us 0.018. So we're going to put a 0.018 here. Now we're going to split this one up, and we're going to call this one, oh, these are testing positive and these are testing negative. See what it says? Positive and negative, okay? Now we're going to do the same thing here. We're going to do testing positive and testing negative, okay? So this says that C, testing positive for non-users, is C, and that's 0.023. So we'll put 0.023 here. And now to get this number, we have to do 0.936 minus 0.023. So let me erase this here. Okay, good. So we're going to do 0.936 minus 0.023, and that number is going to go right here, okay? All right, 0.936 minus 0.023, and that's going to give us 0.913. So 0.913, and you can make sure you did this right. If you add these two numbers together, they should equal 0.936. Add these two numbers together, they should equal 0.064. And then it says, let's read the question. It says, what is the probability that an applicant tests as a drug user, but is actually not a drug user? And look, it shows it right here. That is, what's the probability that they are not a drug user given that they tested positive? Okay, so tested positive, that's going to be the denominator. And so in the denominator, we're going to put all the people that test positive. Well, that's this. So look, positive 0.023 and 0.046. So we're going to put 0.023 plus 0.046 in the denominator. Those are all the people who tested positive. Now we want the people that are not drug users, but they did test positive. So of this and this, these are drug users. These are not drug users, okay, not users. So these are the ones that we want. So we're going to put 0.023 in the numerator, and now we'll put all of this into the calculator, okay? So we're going to do 0.023 divided by parenthesis, 0.023. They got to be the parenthesis, plus 0.046, 046, close parenthesis. And the final answer is 0.3333. This doesn't tell us how many to round to, but the last time we rounded to 4, so let's go ahead and round to 4, 3333. So the final answer is going to be 0.3333, okay? All right, and that's it for calculating whether a person has tested positive, but they're actually not a drug user, okay? That's what we call this, a false positive.